Hi class, Mrs. Tenga here. I'm going to be doing a review for this particular video. So the first one we're going to look at are molar masses, just to kind of review on how to do that. So let's just say you have an element and compound, and keep in mind compound is a combination of two or more different elements. So let's say I have KBr. So to find your molar mass, what you need to do is first figure out how many potassium we have. We have one. How many bromine do we have? Oops, that's also one. After that, you go and look at your periodic table, look at potassium. So I'm going to zoom in. And then you are going to be looking at this particular number. Oops, sorry. All right, we're going to be looking at this particular number right here. Okay, that should have been yellow. There we go. All right, so we're going to look at that number, and then after that, we are going to go and write that down on our list. So that's going to be potassium is, okay, I'm going to zoom out. It's going to be multiplied by, 39.098. And then bromine is going to be right here. Okay, so as you can see, there's bromine. So I'm just gonna write the number for bromine, and that is going to be multiplied by 79.904. So once you find that, you're just gonna add. So that's gonna 2, 1, 1, 0, 1, 18, 19. Sorry, my math is getting fast. So that's gonna be 110, 11. So what you're going to have is potassium bromide will have a molar mass of 119 grams per mole. Okay, so that is how we do our molar masses. Let's do another example, shall we? So let's say our next compound is Na3N. How is that going to work? All right, so what we're going to do is we're going to again write down our elements and then figure out how many of each we have. Sodium we have 3, and nitrogen has 1. So after that, we're going to use our periodic table to look. So right here, you can see sodium is 22.999. All right. So multiply that by 22.990. Then this one, we multiply it by, where's nitrogen? Nitrogen's right here. And that's going to be 14.007. So I'm going to calculate this 22.990, and that would be 68.97. This one is still 14.007. So if we add that, that's going to be, all right, 2 and 1, and here we go. 82.977 grams per mole. Okay. Last example for molar mass. Let's look at lead 3 phosphate. Okay, so I'm gonna make it a little bit complicated. Pb3, PO4, and then a 2. Okay. So how do we calculate this? So what we're going to do is again write down our elements. I know I have Pb, I have phosphorus, and I have oxygen. So for Pb right here, there's a number next to it, which is 3. So that automatically makes Pb a 3. Okay. Now for phosphorus and oxygen, it's a little bit tricky. So as you can see, this number right here, this number applies to everything inside. That means if you have 1 phosphorus, because there's no number right here, then you now, instead of having 1, you're going to have 2, because you're going to multiply the number inside by the outside. So in this case, phosphorus will be a 2, because there's only 1 phosphorus inside, and then you multiply it by the 2 outside. As for the oxygen, you have 4 on the inside and 2 on the outside. That's going to be a total of 8. So now let's look at your periodic table, and then let's go and find out the atomic masses of each of these elements. So Pb is, where's lead? There we go. It's right here. So that's gonna be 2 multiplied by 207.2. And then for phosphorus, phosphorus is right here. So that's 30.974. And then for oxygen, oxygen is right here. And so that's going to be times 15.999. So this is going to be 621.6. And then the next one is 61.948. Take note, I'm getting these numbers because I multiplied those things. And this is 127.992. If you add all of that, that gives you 811.54 grams per mole of lead 2 phosphate. So try to review this lesson so you're ready for your test on Friday.